In this video, we'll look at cognitive development in late adulthood. Specifically, we'll go into how memory changes, um, what cognitive losses are exaggerated in late adulthood, um, neurocognitive disorders, and then also diving into work, retirement, and leisure time. So a quick review of memory, if you remember our memory process, first, we take in information, sights, sounds, and hold them. Oh, why are you doing that? Sorry. Hold them in our sensory memory for a very brief period of time in their exact form. We pay more attention to it. That information will go into short-term or working memory. And short-term memory, we just call it that when we focus on duration. We call it working memory when we're talking about the function, what we actually use it for. And so working memory is our cognitive workspace. If we pay more attention to it, we can get that information into long-term memory. And we, of course, can also pull information from long-term memory into our working memory as well. There are many types of memory and memory processes, and some decline while others remain stable or increase with age. Working memory is more impacted than long-term memory, generally speaking. It is the more active, effortful part of our memory system, right? It's our cognitive workspace. So anytime we have a conversation, solve a problem, that's our working memory. It is composed of three parts: the phonological loop, which maintains information about auditory stimuli or what we hear; the visual spatial sketchpad, which maintains information about visual information, what we see; and then the central executive, which oversees working memory, allocating resources where needed, and monitoring whether cognitive strategies are being effective. So the central executive is the aspect of working memory that is most impacted by age. One study asked adults to learn two tasks and to perform them simultaneously. The young adults were eventually able to learn and perform the tasks at the same time without a loss of speed after having lots of practice. However, none of the older adults were able to do them simultaneously. Long-term memory is divided into explicit or declarative memory and implicit memory or non-declarative memory. So when we say explicit memory, that is memory that we know. We can clearly describe what we know, and it's further divided into semantic memory, which is memory for general knowledge, facts, vocabulary, things like that. Remember, semantic means meaning. So meaningful information, the meaning of words, things like that. And also episodic memory, which is memory of specific events that have happened in our life. Implicit memory, on the other hand, can be further divided into priming and procedural memory. Let me go space there. So priming, excuse me, priming refers to excuse me, being able to, or having our memory prepared or primed to make connections to other memories. For example, if I talk about going to the doctor and then I show you, I show you this and say what letter goes here to make a word, you're likely to say, oh, the letter should be N for nurse. You're much less likely to say purse because you've been primed with that doctor cue, which makes you think of other related terms. Or if I ask you for the definition of the word bark after talking about my dogs, you're more likely to say it's the sound a dog makes, as opposed to giving the definition of the rough exterior of a tree trunk, because again, you've been primed to make a connection to similar information. And then procedural memory is how to do things. So like how to ride a bike and tie your shoes and things like that, drive a car. So episodic memory is more impacted by age-related declines than semantic memory. And it's thought that this is more difficult because it requires essentially two types of memory. You have to remember the event and where the event took place, when the event took place, compared to semantic memories, which are not tied to any specific time and are much easier for younger and older adults to remember, with very little difference in performance. Tests of general knowledge and vocabulary memory showed that older adults often do better than young adults, so better on that semantic memory. However, they also have more blocks at retrieving information that they know. And this is called tip of the tongue events. And I'm sure we've all experienced this where you know something, but you can't quite bring that information out. It feels like it's on the tip of your tongue. And that's what tip of the tongue is referring to. And so in late adulthood, we experience this more often compared to younger adults. In terms of implicit memory, we typically don't see any declines with age for those priming and procedural. Perspective memory refers to remembering things we need to do in the future. When we don't have other tasks competing for our attention, we tend to do well on this. There are two types of perspective memories, time-based and event-based. Time-based, having to remember to do something at a future date, and event-based perspective memories, having to remember to do something when a particular event occurs. When age-related declines occur, they are more often time-based and in laboratory settings as opposed to in the real world. And this is thought to occur as older adults need to be more selective on what they're spending their energy on. Recall versus recognition. Late adults have similar recognition as young adults. And I should probably backtrack a little. What's the difference between recall versus recognition? Recall is having to remember information without any cues. And this is the type of memory that's tested when you have to fill in the blank or respond to an essay question on a test. Recognition, on the other hand, you just have to recognize the correct answer out of different options. And this is used for multiple choice questions or matching questions, are going to force you to use recognition essentially. And recognition is easier at all ages. Okay, so late adults also, as I said, similar recognition to young adults, but starting at 40, adults start to show memory deficits in recall compared to younger adults. Fewer age differences in memory are seen when memory cues are available. Older adults tend to perform better on tests of crystallized intelligence, like with vocabulary words. Late adults also usually have expertise. One example is that older typists, one example is that older typists will compensate for age-related declines in speed by looking farther ahead in the text that they're typing from. And so this helps to offset those declines. So why does memory change? So we have a couple different theories about this. Salthouse's processing speed theory suggests that as the nervous system slows with advanced age, our ability to process information declines. And this theory explains why older adults tend to need more time to make decisions and complete mental tasks. But when they're given plenty of time, they're able to do the tasks just as well as younger adults. Inhibition theory states that older adults have difficulty with inhibitory functioning, or the ability to focus on certain information while ignoring less relevant information. And this theory is supported by directed forgetting research. So directed forgetting is when people are asked to forget or ignore some information, but not other types. An example of this is having research participants memorize a list of words, but then you'd say like, oh, I made a mistake, I gave you the wrong list. Could you memorize this list of words instead, right? So you're asking the participants to forget that first list, memorize that second one. Older adults are more likely to remember words from that first list, the list they're supposed to forget, compared to younger adults. So even though some information processing losses occur in late adulthood, these losses are often exaggerated. One reason for this exaggeration is that the type of tasks people are tested on in research are usually meaningless. For example, memorizing a list of words, right? There's not really much motivation, much reason for me to put forth effort into doing that. When older adults, however, need to recall meaningful information to their lives, they're more motivated to remember, and then they perform better on those tasks. A second reason for exaggeration is the use of cross-sectional designs. This type of research doesn't follow individuals over time, but rather tests people of different age groups at one time, right? And so what happens is that improvements in health and education from one generation to another can exaggerate the appearance of cognitive losses of older generations that didn't have access to those benefits. Consequently, when longitudinal studies are done, the amount of loss shrinks. And remember, those longitudinal studies, when we follow one group over time and see how the individuals change, we have that developmental history there. Another reason for exaggeration of cognitive losses may occur due to a lack of opportunity to use skills. When older adults are given time to practice, right? If it's something they're doing regularly, they perform as well as when they were younger. And then finally, sensory deficits, particularly in hearing and vision, may cause exaggerations in cognitive losses, as if it's harder to hear instructions, or if it's harder to see the words or the symbols that you're being asked to manipulate, that can impact your score. When older adults are assessed using intelligence tests, verbal skills show few to no age-related declines, while performance skills like, solving problems quickly, those skills tend to decline with age. And that aligns with the concepts of crystallized and fluid intelligence. Remember, crystallized intelligence is required for vocabulary tests, solving number problems, and understanding written text. So it's referring to information that we slowly accumulate over time through experience, through education, building on itself. Fluid intelligence, on the other hand, relies on information processing abilities, like remembering lists, logical reasoning, spatial ability, reaction time, more based on raw processing speed. Baltz has added two types of intelligence to reflect cognitive changes with age: pragmatics of intelligence and mechanics of intelligence. So the pragmatics of intelligence are cultural exposure to facts and procedures that are maintained as we age and are similar to crystallized intelligence. Mechanics of intelligence are dependent on brain functioning, and they tend to decline with age, similar to fluid intelligence. Additionally, the pragmatics of intelligence may help us compensate for declines in the mechanics of intelligence so that global cognitive decline does not occur, right? We're able to compensate, and so we don't see a big drop in performance. We also may have wisdom, which refers to the ability to use the accumulated knowledge about practical matters, and that allows for sound judgment and decision making. Although age brings experience, it doesn't necessarily bring wisdom. People are more likely to gain wisdom if they are in occupations or have experiences that emphasize others rather than themselves, and if they are high in traits like openness to experience and generativity. So moving into neurocognitive disorders. So the term dementia has been replaced in the Diagnostic and Statistical Manual of Mental Disorders, the DSM, version 5, with the term neurocognitive disorder. So if you're familiar with the term dementia, this is just a new name for it, essentially. So there is major neurocognitive disorder and minor neurocognitive disorder. A major neurocognitive disorder is diagnosed as a significant cognitive decline. So that's kind of our big difference here, having a significant, I'll shorthand that, significant cognitive decline from previous level of performance in one or more cognitive domains. And that interferes with independent functioning. So significant decline interferes with independent functioning. Compared to minor neurocognitive disorder, where there's a modest cognitive decline from a previous level of performance in one or more cognitive domains, and does not interfere with independent functioning. No interference with independent. Okay. We have several different neurocognitive disorders that can occur during late adulthood, and most of them are more likely to occur during late adulthood. And determining which one is present can be pretty challenging because the symptoms often overlap. So diagnosis typically includes a medical history, a physical exam, lab tests, and noting behavioral changes. So we'll look at Alzheimer's disease, vascular neurocognitive disorder, and neurocognitive disorder with Lewy bodies. So first, Alzheimer's. It is the most common neurocognitive disorder for late adults. It accounts for about half of all neurocognitive disorder. So 5.4 million Americans were diagnosed with Alzheimer's in 2016. And so that is about 1 in 9 who are 65 or older. It is projected to be 13.8 million by 2050 if no breakthroughs occur. Alzheimer's is also the 6th leading cause of death in the United States, but the 5th for those who are over 65. The Alzheimer's symptoms are subtle at first. There's typically pretty mild changes in memory loss, and then they gradually progress to confusion, difficulty with change, and a decrease in language, problem-solving skills, and changes in personality. In the later stages, the individual will lose coordination and no longer be able to take care of themselves. Finally, individuals will stop responding to their environment. They become unable to carry on a conversation, and they lose voluntary muscle movement. The average time until death from Alzheimer's is 8 years. However, it can be as long as 20, depending on several factors. The greatest risk for Alzheimer's is age. There is also a familial type of Alzheimer's disease that is genetic, and that type tends to cause early onset, with symptoms beginning to show in one's 30s to 50s. Only 5% of people with Alzheimer's are under 65. So again, age is a large risk factor, but there are other risk factors as well from the environment, things like traumatic brain injury, obesity, hypertension, high cholesterol, and diabetes. Alzheimer's disease occurs due to specific changes in the brain. So neurons die. There we go. Neurons die, and neurons, remember, are nerve cells. They make up our brain, our spinal cord, and all the nerves that run throughout our body. So neurons, they die, and the connections between those neurons, our synapses, break down, and we get an extensive formation of plaques and tau interference with neuron functioning and neuron survival. And you can see on the slide here, showing some depictions of what happens at the neuron level in a person who's healthy compared to a person with Alzheimer's. And we'll talk about those amyloid plaques and the neurofibrillary tangles in a minute, and then how the overall volume of the brain shrinks as those neurons die. Again, seeing a healthy brain compared to someone with severe Alzheimer's disease. So amyloid plaques, these form outside of the neuron. They're dense, abnormal formations of this sticky beta amyloid, and it comes from a larger protein in fatty membrane surrounding nerve cells. These plaques may become surrounded by clumps of dead nerve and glial cells, and they end up blocking communication and triggering an inflammation response from our immune system, leading to further neuronal death. Neurofibrillary tangles, on the other hand, are inside of the neuron, and they're bundles of twisted threads that occur when tau, a protein that helps maintain the brain's transport system, malfunctions. So these collapsed structures prevent nutrients and other supplies from moving through the cells, and eventually will cause the neuron to die. The brain shrinks as neurons in many areas, such as the hippocampus and the frontal and temporal lobes, die out. The death of neurons also leads to a shortage of various neurotransmitters, such as acetylcholine, which is key for things like movement and learning. The amyloid plaques tend to appear first, but they do not cause Alzheimer's on their own, but rather they're thought to cause microglia, immune cells, to fail, and thus allowing the plaques to injure other neurons and providing an environment for the tau tangles to form in. Studies have found that sleep is very important for allowing our brain to clear beta amyloid and tau. Studies have compared people who got a full night's sleep to those who stayed awake all day and night. They found that beta amyloid increased 5% and tau levels were elevated 50% in individuals who missed a night of sleep. A healthy lifestyle can help to decrease the risk of Alzheimer's disease. I mean, if you don't have the genetic type, I mean, that one's genetic, so very difficult to do much about. So doing things like eating a healthy diet, they refer to the Mediterranean diet, a diet that is high in omega-3 fatty acids like fish and olive oil, healthy fats, and even a little bit of red wine to help protect the body. If you engage in that 150 minutes per week minimum of moderate to vigorous physical activity, if you don't smoke, light to moderate alcohol intake, and engage in cognitively stimulating activities. People who did 4 out of 5 of these activities had a 60% lower risk than those who did none or only one. And if you'd like to know more about what you could do to help prevent Alzheimer's disease, there's a great TED Talk by Lisa Genova, who's the author of Being Alice. And I'll put the link to that TED Talk here in the module. So other neurocognitive disorders, the second most common vascular neurocognitive disorder. It impacts about 0.2% of 65 to 70-year-olds and 16% of people 80 and older. Unlike the general loss of brain cells as seen with Alzheimer's disease, vascular neurocognitive disorder is associated with a blockage of blood vessels. So, I mean, vascular, right, relating to the blood vessels, and it affects one part of the brain rather than the whole brain. Vascular neurocognitive disorder also starts more abruptly and tends to have a shorter course than Alzheimer's, and males are more likely to be affected than females. Whereas with Alzheimer's, females tend to be at greater risk because they do generally tend to live longer. Risk factors for vascular neurocognitive disorder include smoking, heart disease, diabetes, hypertension, and a history of strokes. Essentially things that interfere with your blood vessels, right? Or cause increased pressure on your blood vessels. The third most common type is neurocognitive disorder with Lewy bodies. And Lewy bodies are these protein deposits in neurons that can occur in both the cortex and the brainstem. They affect chemicals in the brain and lead to problems with thinking, moving, behavior, and mood. There are slightly more males than females affected by it, and generally it begins at 50 or older. Typically, people live 5 to 7 years after diagnosis, but it can range from 2 to 20 years depending on various factors. People with neurocognitive disorder with Lewy bodies experience tremors and muscle rigidity, similar to people with Parkinson's disease, yet different in that the motor and cognitive symptoms occur at the same time. With Parkinson's, you see those motor symptoms occurring first, and later the cognitive symptoms start in as well. But for vascular neurocognitive disorder, not vascular, sorry, with neurocognitive disorder with Lewy bodies, cognitive and motor symptoms occur at the same time. People with neurocognitive disorder with Lewy bodies also tend to have sleeping problems, visual hallucinations, and are at a risk of falls. Switching up a little bit to talk about work. Many people continue to work in late adulthood, with more than 40% of Americans in their 60s still working, 14% of people in their 70s still working, and 4% of people 80 and older still working. Even though late adults make up a smaller number of workers, those between the ages of 65 and 74 and those 75 and older will have the fastest growth rates in the coming years. And that is what the graph is showing on the slide, the percentage of labor growth by age group. So for 16 to 24, it's going to decrease. And if you go down to the older age groups, big increases there. Older workers tend to have more education and are more likely to be male. Late adults are just as capable as younger adults and often better in jobs that require social skills, accumulated knowledge, and relevant experience. Late adults also have lower rates of absenteeism and tend to be more invested in their work, so they're less likely to change jobs or not come in. Retirement. This is typically a process rather than a single event, with about 60% of people going into a bridge job. A bridge job is typically a part-time job that you take on between your career and full retirement. After fully retiring, about 15% of people get a job, either due to needing the money or because they're not enjoying their retirement. Sometimes these jobs are known as encore careers, which is a job in a field different from the one that you retired from. In 1910, the average age of retirement was over 70 years of age. However, it declined to 63 in the early 1980s and is now at roughly 65. However, 18.5% of people over 65 still work, which is an increase, significant increase of 6.5% from the 12% that were still working over the age of 65 in 1990. While the Age Discrimination in Employment Act prevents a mandatory retirement age for most occupations, there are a few exceptions to this rule. For example, pilots, air traffic controllers, federal law enforcement, national park rangers, and firefighters have mandatory retirement ages for safety reasons. Social Security benefits also influence when one retires. So the age at which you qualify for full Social Security benefits depends on the year you were born. So you get full Social Security benefits at 65 if you were born before the year 1938. It's 66 for those born between 1943 and 1954, and it's 67 for those who are born after 1959. Taking Social Security benefits early results in a significant decrease in benefits. So that's definitely something to consider. And also Medicare, you don't qualify for Medicare until you're 65. Delaying retirement is usually due to financial reasons. In the past, retirement income consisted of Social Security, a pension plan, and your individual savings. Many pension plans, however, lost value during the 2008 recession. So many people had to compensate by continuing to work. It is difficult to get a job in late adulthood, particularly for people with disabilities, single women, the oldest old, and people with intermittent work histories. Others may delay retirement for the health benefits and social interaction that working brings. A one-year delay in retiring was associated with a decreased risk of death for both healthy and unhealthy people. Actually developed a model to help illustrate how retirement is often a process. So the first stage is remote pre-retirement phase. So when retirement's still off in the distance. And this is when we fantasize about what we want to do in retirement. What would you like to do after you retire? Will you work part-time? Will you travel? Do a little of both? Something else, right? The immediate pre-retirement phase is when you start to make those concrete plans. And then there's actual retirement, followed by the honeymoon phase. And typically this is when retirees will travel and participate in activities that they didn't have time to do while they were working. The disenchantment phase, this is when retirees experience an emotional letdown. So that honeymoon phase ends and kind of reality sets in, and maybe they realize it's not everything that they thought it would be. The reorientation phase entails retirees trying to adjust to retirement by maybe making less hectic plans and getting into a more regular routine. So post-retirement is most anticipated by those who expect to have adequate income. Staying active and socially engaged is very critical for physical and mental well-being. Volunteering, caregiving, and informal helping are great ways to stay engaged and productive. Older adults can also improve their well-being by going to college. A survey of retirees 70 years or older found that 58% retired earlier than they had planned. Many sought additional skills training in order to return to work in a second career. Continuing education programs are a great way to keep the mind active, even if you aren't pursuing a degree. Rhodes Scholar is an organization that combines college classroom time with travel tours and experiential learning. It serves more than 100,000 people per year in the United States and abroad. Continuing education courses may be academic. They may focus on practical skills like budgeting or using computers, or be more interest-based, like learning to play an instrument or make pottery. Leisure time for Americans 60 and older has been about 7 hours a day consistently over the past 10 years. The amount of screen time, however, has increased to the point of taking up more than half of total leisure time. Only 14% of people 65 and older use the internet in the year 2000. Now it's increased to 73%, with 53% owning smartphones. People with less education typically spend more of their leisure time on screens and less time reading or exercising compared to people with more education. And that wraps up cognitive development in late adulthood. Thank you.